Hello everyone and welcome to my YouTube channel. In today's video we are going to take a look at a crazy idea. So what we are going to do is we are going to use InstructBLIP, which is a model in Hugging Face transformers now. It was released by Salesforce and it's a instruction fine-tuned version of blip 2 model, which enables chat conversations about images. So we're going to use this model to generate some really extensive descriptions of images, and then we are going to use FAISS and sentence transformer to build a semantic search, but for the content of the image. So I hope there will be a huge difference between this and simple image captioning model, because those are not really extensive. And I hope what we build will be able to search for even small things or small details inside images. So Salesforce has released 4 checkpoints, 2 of them leverage Vicuna. So we are going to use Vicuna today, and 2 of which use Flan T5. So let's take a look at this notebook and see what InstructBLIP is really capable of. So here you see, like, we load the processor and the model, but in right now we are just looking at an example. So let's say this is your image, and now you want to talk to this image, talk to the model about this image. So if you ask something like, what is unusual about this image, and this was the image, and there are obviously few unusual things, or at least one unusual thing. So hopefully the model will tell you what's unusual. So here the model says the unusual aspect of this image is that man is washing clothes on the back of yellow SUV while driving down a busy city street. Okay, great. So it's a funny image. He's not actually washing laundry, I think he's ironing clothes, but still funny, right? So we can also ask, like, follow-up question, which city do you think the image is taken? So the answer here is New York. I think it's because of the color of the taxis. Maybe not entirely true, but anyways. So this is how InstructBLIP works. So what we are going to do is we are going to collect some images and use a little bit better prompts for it to generate image descriptions, and then we are going to use sentence transformer and FAISS to build a semantic search. So let's get started. Great, so I'm in my coding environment, VS Code, and now we can start writing some code. So let's create a file called create descriptions. Create descriptions.py. So the idea here is, in this file we are going to create descriptions of all the images that we have. So first things first, let's import a few things. I will import torch, and I'll import from datasets, import load dataset. So I've already done this coding yesterday, and I'm keeping a reference, so I'm not writing everything from my memory. I do have a reference with me. And from transformers, import InstructBLIP for conditional generation, and InstructBLIP processor. So one thing you have to remember, if you want to use InstructBLIP right now, you have to install transformers from the Git repo. Okay, so now we say our model is okay, so our model is InstructBLIP for conditional generation dot from pre-trained, and here you can write the model name, which is Salesforce slash InstructBLIP Kuna 7B. So here we got our model, and we will load the model in 4-bit to save some memory, so that it also, if you load that in 4-bit, it will also run on your local home GPU machines. And we will define torch dtype equal to torch dot bfloat16. Okay. Similarly, we have the processor, and my processor is InstructBLIP processor from pre-trained, and here I can just write this same name. Okay, so now we got our model, we got our processor. Now all we need is some image datasets. So I have created a list of datasets. So I went to Hugging Face datasets and looked for some image datasets, and then chose randomly some of them. So we can define datasets in here, or you can just use URLs or anything you like. So this is the way I'm doing it, because I found it to be the easiest for me, but you can define datasets as you like. You can use your own custom set of images. I've copy pasted some of the datasets that I found to be useful for this demo. So one is fashion PDF, some fashion datasets. We have NFL object detection, plane detection, snacks dataset, some pets. So it's a mix. Pokemon dataset. So it's a mix of all different kinds of datasets. The second entry is the config, and the third one is the split. But as I mentioned, you can load datasets the way you want. The idea is to just create a description using InstructBLIP. So here I will set a counter, and I will say my counter is 0, and then for name, config, and split in datasets, we'll go through each and every dataset, we'll download the datasets, we'll select some of the images and create the descriptions. So I can say D load dataset, and here comes name, config, and split is split. Great. So what I'm doing now is I'm selecting only a few images, because I didn't have patience to run through all of them. So I can say if, or let's forget this part. Okay. So we can say for IDX in range len of D. Here we can load the image, and all our images will be PIL images in RGB format. If you don't have PIL images in RGB format, maybe you need to convert it to that format in order to use the same code. So my image is IDX, and here comes image. So I checked all the datasets, and the image column is image, so I don't have any problem here. Now I will generate a description for this. So let's create a prompt. So we can also create two prompts, so prompt 1 and prompt 2. So I have come up with two different prompts. One of them says, describe this image in full detail. So I can just paste it here. Describe this image in full detail. Describe each and every aspect of the image so that an artist could recreate the image. And I'm seeing that this kind of prompt is giving me much better results than image captioning models, general image captioning models. But obviously, I didn't explore a lot, so you should do your own experiments. And my second prompt is create an extensive description of this image, which is similar, but with this prompt, I've seen the descriptions that are generated by InstructBLIP are not are maybe like just one sentence, but with the first prompt, I get really very extensive description. So once I have all this, I can just start creating the descriptions. So we come back here and I say for underscore prompt in prompt 1, prompt 2. You can have as many prompts you want. You can do it in many different ways. My inputs will be processor, images is image. We have a single image here. Text is underscore prompt. And return tensors. So let me just make this pretty. Return tensors is PyTorch. Okay, so we have this, and then we can just do to model.device, so device which model is on, and also we can specify the D type torch.b float 16, same D type as a model. So now our outputs will be model.generate, and here we can write inputs, and then we have all these different parameters to the model, and these parameters really matter a lot, so you need to experiment with them quite a lot. Numbeams 10, max length 512, min length. So I want really extensive descriptions, so I'm keeping max length a little bit higher and min length higher too. Top p to 0.9. We can add some repetition penalty, and we can also add some length penalty. Repetition penalty equal to 1.5. Temperature equal to 1. Okay, I think this is good enough. So now we can write my generated text equal to processor dot batch decode. So we have got our output. Now we send it to the processor again. Output and skip special tokens go to true. And since we have this is a batch function, we can also just do 0, the index 0. That's all we need, and we can add a strip to remove the extra white spaces from left and right side. Okay, and my description is now description plus generated text plus whatever. Okay. So once we have the description, so what I'm doing is I'm taking two prompts, I'm generating descriptions from both of them, I'm combining them with the space. That's all I'm doing. Description equal to dsc.script. And you should also remove /n. So you should remove /n here or /t. So things like this, I think you should take care of. Otherwise, you're going to have a problem later when you're loading the dataset, because I had the same problem. And we are going to save the images in a folder called images. So we can also create it programmatically. I just created manually. And I can do image.save. Save it in a folder called images. Okay. Images. And here you have the counter. So slash counter .jpg, whatever. Okay, yeah, that's it. We can also print counter and description, and we also need to save the descriptions to some file. So with open, we'll save them in a CSV file. So that's why removing /n and /t is important. But this is also not going to be a real CSV file, because we should also encode the second column, but we are not doing that. So we are just going to load it in a different way when we are loading it. So we have f counter, comma, and here we can have description, and then we add a /n, and here we can increase the counter. So doing it this way, the advantage is if it crashes, you just have to update the counter to the latest counter in the description.csv file, and then you're good to go. You're good to resume. torch.cuda.empty cache, so that you don't run into memory errors too often. And you will run into memory errors, but hopefully not too often. Okay, so now since we have this, we can just go to and we can just do Python create descriptions, and it should start generating the descriptions for me. So let's take a look at few of them, and then we can move to the next part. So we do have a error, prompt 1. Prompt 1. Okay, hopefully no more errors, so we just run it again. So I think I've made a couple more mistakes. I used the wrong spelling for repetition, so we'll fix that, and this has to be true instead of false, so we have to load in 4-bit. That means we need to restart it one more time. I hope this works now. So we finally got it moving. So this is how the descriptions look like, and you can see it's quite extensive. Man in gray suit, bow tie, pair of sunglasses. So that's our first image, and we can also take a look at the image and see. That's quite a good description, right? There is a yellow door, potted plant on the left side of the image. So that's a quite good description. I think it's much better than image captioning models, but obviously I'm not 100% correct there, because it's not a claim that I'm making, so you have to verify yourself. So I can just let it run for a couple hundred images, and then we can take a look at the next part, which is generating the embeddings using sentence transformer and then creating a FAISS index. So let's get started with that. So after like generating 200 odd images with the descriptions, we can create the embeddings for them. And you can generate thousands of images if you want. You just have to let it run overnight on multiple GPUs, multiple instances. It's up to you. So from sentence transformers, we import sentence transformer. Okay, and we import pickle to dump the embeddings file, and we import pandas. So my model here is, you can choose any model from the hub. Even if it's not sentence transformer, you can use BERT or StillBERT or Roberta and do a mean pooling, but we are using sentence transformers. Sentence transformers, and here we will be using all MPNet base v2. This is, I think, one of the best models that I've found, with open descriptions.csv. So if we would have saved the file as a real CSV file, then we could just use pandas. But now we have to do some data processing. So lines is f.readLines. And we can just do some processing here. Lines, line.strip, dot split by a comma for line and lines. And now my lines become for idx, comma, line in enumerate lines. We just need to fix all the lines. So idx, so this will be line 0, comma, and then we can join by a comma because we split by comma. So dot join. In case we are generating commas, which is not ideal, we could have just removed them, but I was lazy. And now we have the pandas data frame, pd dot data frame, and here we have lines, and the columns are idx or id, whatever, id, and description. Okay, so we have the data. Now we create the embeddings, which is just one line of code. Embeddings is model.encode df description dot to list. That's it. Show progress bar in case you want to see the progress bar. So this will generate, like if I have around 200 samples in df, this will generate a matrix 200 cross 768 depending on your model. Now we can dump the embeddings file. So embeddings.pickle and share wp binary file as f pickle.dump embeddings, comma. Okay, so that's it. Now let's run this code and see like if we are able to create the embeddings. We can also probably just add here print embeddings dot shape. Okay, let's run it now. Python create embeddings. This looks like a very simple code. Okay, so we do have a problem. Let's see. Descriptions.csv, lines. We have the lines here. Let's print the data frame. Let's see if we are having any issues with the data frame. Aha, we have an issue in this line. Okay. So this should be line 0. Oh, line 1. Okay. I hope that should work. Let's see. Okay, so that works. So I also see like for some images it's always adding from scratch. I don't think that's required, but probably due to the model. So it's anyways, I have 194 images now, and for each image we have a vector which is 768. So now we can just build the FAISS search. And we can use it like we can use Gradio for easy demo. So let's get started with the third part. So here I will create a new file called app.py and import Gradio as gr. We import pickle. We import FAISS. We import numpy. And we import sentence transformer from sentence transformers. Import sentence transformer. Okay, so we have our model, which is sentence transformer model. So I can just copy it from here. We have our embeddings. So with open embeddings.pickle. Embeddings is pickle.load f. And we can also make it float 32 embeddings dot as type. Float 32. Okay, and embedding size, we can just say embedding size is embeddings dot shape 1. We can also just write 768. Number of clusters, so let's say 5 clusters. You can have more clusters if you want to, depends on your data. These are hyperparameters. And num results equal to 5. We get the top 5 results. So now we have to build FAISS quantizer and index. Quantizer is FAISS dot embedding size, and another one is index. I'm not very proficient with FAISS, but it works. So that's it. Index. You can also store like in a different DB, and you can do a lot of crazy things with this. Here we'll have the quantizer, embedding size, number of clusters, and the FAISS metric. FAISS dot metric inner product. Okay, I think it looks good. So now you need to train FAISS index. So you can just write FAISS dot, index dot train, and here you have to pass the embedding matrix, and then you have to add the embeddings to the index. That's it. So now you have your FAISS index, you have your model, you have the embeddings itself, and now we can create a simple function called search, and here it will take the query. So my query embedding, I can just get the same from the model. Query embedding is model.encode query. Okay, and now we need to convert it to an array. So I can just say query embedding is numpy array dot as type, ensure that it's float 32. Okay, and then we reshape it. -1, 1. So here, 1, -1. So here we have only one sample. So the shape should be 1, something, not just a simple vector. So now I have my distances, and indices is index.search. So we can directly search the index, query embedding, and number of results. So we are not interested in distances a lot here, so I'll just hide it. We are interested in indices, and for each index we have an image. So let's get the image. So images will be f images slash, here you have I dot all our JPG images for in indices 0. So if you print indices, it will be a list of list or matrix. Since you have only one sample, you need the first list, and return the images. So this will give you a list of images, but it's obviously much better to take a look at them. So we can use a simple radio blocks with gr.blocks as demo. Here we have query, which is a Gradio text box, and lines is 1, label anything, query, search query. Okay, outputs can be shown in gr.gallery, and we enable the preview mode. So we have small icons at the bottom, and we can see the images when we click on them. And we need a submit button. gr.button value is search. So when we click on the submit button, it should run the search function, and my inputs should be query, and my outputs are the image paths, and they are shown in outputs. And I can just do demo.launch. So now let's run it and see if it works. So I forwarded the port, go to the terminal and run python app.py. Okay, yeah, let's go to Chrome. Oh, sorry, Firefox. So we are in Firefox now. And you can see the search query box. So let's search for something. Let's search for a girl wearing a red dress. It's pretty good, right? And all these images are coming from the images from datasets I had. So you can also use all your local images, or I don't know, building a website for that, or fashion images or things like that. So if I search for a black and white cat, let's see what I get. It's pretty cool, right? And it's also quite fast. So I'm surprised. I think I see some duplicates here, but doesn't matter. It works, and that's what I wanted to check and show you if it works. Or if I see maybe a picture of Pikachu, because I remember I had a Pokemon dataset. But yeah, here it is. Pretty good. A fashion show. I had some fashion dataset. Okay, so now I'm getting pictures from a fashion show. Yeah, so it works, and yeah, I'm also quite surprised that it works. But it's quite good, and it didn't take us a lot of time. So I guess I'll end the video here. And if you have any questions, feel free to ask me in the comment section. And if you like the video, do click on the like button, do subscribe, do share it with your friends, and see you next time. Goodbye.